Okay, my talk is about something different from what you heard in that session. I will talk about an evaluation of 2D and 3D imaging systems for laparoscopic surgery from the user perspective. The research has been undertaken by two groups in Germany. One group of medical experts from the University Hospital in Munich, and one group of human factors engineering experts from the Fraunhofer Heinrich Hertz Institute in Berlin. And as John said, I'm Detlef Ruschin from Fraunhofer. Okay, let's start. Well, 3D imaging systems for laparoscopic surgery have been around for more than 2 decades. And there's a large body of research showing that it's beneficial to use stereoscopic imaging in surgery, so you get better results. It's better for the patients, better for the surgeons. And nevertheless, these systems have never quite made it into the operating rooms, probably because of the vision and eye problems that have been reported with early systems. So the visual discomfort was always a big topic in that. There might have been other reasons for these systems not to penetrate into the practice. Another thing is that sometimes you read that only novices profit from 3D imaging, so that there's a myth that once you're an experienced surgeon, you don't need your eyes anymore, so your hands know everything that you need to do. And that may prevent some people from buying such stuff for the operating room. But now we have new products on the market, 2D and 3D products, and we have always new products in the labs, of course, and that was a reason to reevaluate the myths I mentioned and other things like whether the eye problems are still there. And in detail, our questions are the following. The first thing is that can we reconfirm that stereo is beneficial in minimally invasive surgery, like laparoscopy, which we expect on a theoretical basis, but of course with every new investigation you have to recheck for that. Then we have a perhaps rather odd question. When 3D systems are improving, is there an asymptote, or what is the asymptote? How good can you get? And we try to answer that question also with our research. And how far away are we from that asymptote? Also, we wanted to see whether we can bust that myth that stereo is nothing for experienced surgeons. And last not least, it was interesting whether all these claims about visual discomfort from using the 3D systems are still valid. What we did was, of course, an experimental investigation. We composed 4 different imaging systems, which we then compared, partly consisting of commercial components. First, we had the first system, an autostereoscopic display, a prototype produced in my institute, in the Heinrich Hertz Institute, driven by a 3D endoscope by the Storz company in Germany. The next system was a 3D display from Sony, combined with the same stereo endoscope from Storz. Then we had a 2D system provided by Storz, 2D monitor and 2D endoscope. And that one I will explain in a minute, a mirror display that has no electronic transmission, that we constructed as a kind of gold standard or for benchmarking 3D systems in the future. Just a short look at the autostereoscopic system from our lab. As you see, it's a portrait type display. The reasons for that I can explain in a coffee break. It has a head tracker. We have stereo cameras here that tracks the user, finds its eyes, and uses the information about the spatial position of the eyes to adjust the lenticular lens plate using voice call motors. So the lens plate can be shifted left and right and forward and backward to make sure that the viewer's eyes are always in the sweet spot of the autostereoscopic system. That's the mirror display we constructed, and let me briefly explain it. We have one mirror here onto which the surgeon is looking, and it's in the same position as where you would place your ordinary LC panel-based monitor. But this mirror just mirrors the image of another mirror positioned here, and that mirror looks, so to say, at the surgical target here, down here. So altogether, the thing looks like that. The setup looks like that. In terms of the physical arrangements, it's similar to the usual operating situation in laparoscopic surgery. To have the same size or approximately the same size images as on the electronic displays, we introduced a magnifying lens here. Also, you can see that it's a Fresnel type lens, and that served also as a pivot for the instruments of the surgeons. So we drilled little holes in there, and the instrument were poked through these the holes in the Fresnel lens plate. Okay. The task our subjects had to perform was to make a simulated suture on a kind of dissected gut that has to be reconnected. Thanks. You see how it is done. We have two layers of tissues here. One dissected one that has to be reconnected with the suture. We have another layer of tissue down there, and it's important to first to hit the marks correctly, so to place the needle right in the middle of the marks, and it's also important not to hurt the underlying tissue here, so like in reality. And yeah, you see that wavy motion here that comes from two imaging, because the surgeon doesn't know how far he is away from the target. And that goes on and going on, and the task stops when you have penetrated here. So it's a continuous suture task. That little thing here is called a knot bench. I've brought one here if you want to inspect it later. Okay, that was the setup in the lab. On the left you see the mirror display. On the right you see the other displays or the other imaging systems, the 2D display, the 3D display with glasses based that the female surgeon is just using, and the autostereoscopic display here. So all comparable setups, same lighting conditions. We try to adjust the brightness levels of the displays in the same way as good as possible. our test subjects, we divided into two groups. We had 48 surgeons altogether, 24 novices and 24 experienced surgeons. The criterion was the number of laparoscopic operations previously performed. Our experts had on average about 800 operations, and as you see here, the novices, the beginners, less than 100. The test was for everybody to use all the 4 systems, and they had to use them in a completely random order to average out learning effects. We did a lot of measurements during the task, objective and subjective measurements, and I guess that's the reason why we call the study comprehensive, not because we had so many systems under inspection, but because of all the different types of measurements we made. The first one is the objective, the measurement, performance measurement. Some examples are result quality. We had a rating system for the quality of the suture, the path length that was used, how long it took, and some efficiency measure here. And on the subjective side, we used the Reiser task load index. We have had the test subjects perform depth quality ratings using the ITOR scale. We produced a visual discomfort questionnaire adapted after Okuyama, who presented that here on that conference in 1999. And also a usability questionnaire was administered, and the subjects had to perform also a preference ranking for all the systems. They had to say, I like that best, and that second best, and that, so on. Just the results. Or some of the results concerning performance. As you see here, that's what we intended and expected, is that people perform best with the mirror display. Here, so second best, also as expected, with the commercial 3D system here, and less good with the 2D system, and very badly with the autostereoscopic display here. If you look at the task times, the picture is completely the same or complementary. So the fastest performance was with the mirror display, the second fastest with this 3D, commercial 3D system with glasses, and worse than those two were the monoscopic system and the autostereoscopic system. We can skip that. The Reiser task load index. I don't know if you're familiar with that, but we have a questionnaire with 6 items asking for subjective load, mental load, physical load you experience, and so on. And you can get a maximum of 100 points, which means 100 points is very strainful task, and 0 points is when you do nothing. What you see here, that the task was easy because we are in the 40s here, which means that's like talking to somebody or something, and so you can't do very much with the task load index here. There are differences though. Again, the autostereoscopic display was somewhat less easier than the other ones, and you have the typical order here that the 3D display produces the smallest load, but the figures are so similar that you wouldn't say that makes any difference. It doesn't make any difference. The depth impression rating is very interesting. We have the best rating with the commercial 3D display, not so good with the mirror display, which hints me to the fact that depth is somewhat exaggerated with the using the combination of disparity and magnification in the endoscope and display combination. And of course you have bad depth rendering in the 2D display, and well, that needs explanation. Again, not so good in the auto-stereoscopic display. Visual discomfort, just to say it briefly, is a non-issue nowadays. So you could achieve 6 points for very bad systems, and we'll be around 1 with all the systems. So that there's no visual discomfort anymore. And concerning the ranking, well, on the first rank has been occupied by the commercial 3D system. Here, the picture is somewhat different if you compare the mean rank. So on average, people think that this system is as good as the 2D system, which needs discussion. My interpretation is that there's a conservative element there, that people stick with the proven technology somehow. And yeah, to come to the conclusion, we can skip that. I've explained everything. I should say that there's no good reason not to use 3D imaging in the operating room nowadays. You can use the mature commercial systems. You have benefits for the patient and for the surgeon, and you have no problems, no eye and vision problems, obviously, with that. We hope that the autostereoscopic systems can catch up a bit in the future, because they currently obviously don't perform so well. We can discuss the reasons for that again later. But when they become maturer, obviously they would provide a usability advantage, because you don't need the glasses, and you don't clearly better if the performance and other factors are equally to the glasses-based system. And of course, maybe you have seen that. Otherwise, I go back to the first thing again. You see that the benefits that novices and experienced surgeons have are the same. So even if you're a well-experienced doctor, use a 3D system and you will perform even better. Thanks.